All right, so we begin. A bag contains 3 red and 2 white identical balls. 2 balls are picked at random from the bag, one after the other, and with replacement. Find the probability that they are of different colors. All right, so it's a multifaceted question, but there are 2 ways this can happen, right? Is either you first pick a red, then you pick a white, or you pick a white, then you pick a red. All right, so we're going to calculate for each of them, and then remember that there is with replacement. So let me draw something here. So we have three red and 2 white balls. So let me see if I have, okay, so I have white colors. Let me do red first. I'm drawing 3 red balls and then 2 white balls. Okay, I hope you can see that. So 3 red and 2 white balls. Okay, and so the probability of picking a red and then a white, we have to calculate that. So the probability of picking a red the first time would be 3 out of 5, right? Because we have 5 balls and then 3 of them are red, times the probability of picking a white. Now, because we return the red, that means the total number of red remains 3 and the total number of balls remain 5. All right, it's not like we did not replace it. So we are always going to keep on working with this system. This system will never change. All right, so for white it is 2 out of, so for white it is 2 out of 5. Okay, because the red ball was replaced, so the total number of balls is still 5. So, or, which means you add, right? You add, the chances of this plus the chances of the other one. For white, we would have 2 out of 5, then red. So if you pick a white and then you pick a red, the white will be 2 out of 5, and then chance of picking a red the second time is 3 out of 5. So we'd have 6 over 25 plus 6 over 25, which gives you 12 over 25. So there's a 12 in 25 chance that you would have different colors, right? Either a red or a white, either a red and then a white, or a white and then a red. Okay, number 2. A bag contains 3 white, 6 red, and 5 blue balls. So let me draw that here. So we have 3 white, 1, 2, 3. All right, 6 red. So let me use this. I know it's not exactly red, but 1, 2, 3, 4, 5, 6, and then 5 blue balls. 1, 2, 3, 4, 5. The ball is picked at random from the bag. What's the probability that it is either white or blue? That will be the probability of it being white, all right, plus the probability of it being blue. Probability of it being white is 3 out of, let's add that up. That's 3 plus 6 plus 5, that's 14. So 3 out of 14, plus probability of it being blue is 5 out of 14. So we have, that will be 8 out of 14, or 4 out of 7. 8 out of 14 or 4 out of 7, that's 8. Question 3. A bag contains 4 red, 6 black, and 6 black balls of the same side. If the balls are shuffled briskly and 2 balls are drawn one after the other without replacement, okay, so let's find probability of picking balls of different colors. Okay, so we have 6 red, 4 red, 4 red balls, 1, 2, 3, 4, and then 6 black balls. 1, 2, 3, 4, 5, 6. All right. So now we're trying to deal with without replacement, right? What's the probability of picking balls of different colors? So if I'm going to pick balls of different colors, there are 2 ways it can happen. I can either pick a red and then a black, or I can first pick a black and then a red. Okay, now is without replacement, so it's going to be a bit tricky. So let's look out for that. So the probability of picking a red ball the first time will be 4 out of 10, right? Then the probability of picking a black, now because one red ball is gone, all right, because one red ball is gone, then the probability of picking a black would now be 6 out of 9, right? Because one red ball is gone. So then plus, let me go and put my red ball back so that we can now do the second possibility, right? So I put my red ball back, and then let's look at it. We'll go again. It's going to be probability of picking a black first. Probability of picking a black first would be 6 out of 10 times. Now, because that black ball, I won't return it, right? The probability of picking a red now would be 4 out of 9. So we can reduce this, right? Well, 2 here, 2 here, 5, 3 here, 2, 3 here, 3. So that's 4 out of 15, right? Plus 2 here, 2 here, 5, 3 here, 2, all right, and 3 here, 3. So that will be 4 out of 15 again. So when you sum that up, you get 8 out of 15. All right, so that's option B. Okay, question 4. A bag contains 5 red and 4 blue balls. They are selected one after the other with replacement. So 5 red and 4 blue balls. All right, so let me draw 5 red balls and 4 blue balls. So 5 red balls will be this: 1, 2, 3, 4, 5. Okay, and then 4 blue balls will be this. So 2 balls are selected at random without replacement, one after the other. So find probably that the first is red. Okay, so we want to find that the first will be red, and then the second will be blue, and then the second will be blue. So quick rule, right? I'll just mention it here, is that when you have an OR situation, all right, that's a single trial but multiple options, multiple outcomes, all right, but a single trial. So that you add, all right. But when you have multiple trials, one trial and another trial, so there are 2 trials that you're trying to say, okay, this happens in this trial first, and then it happens in another thing happens in the second trial. You're looking at 2 different trials, all right. That's a multiplication. So people just say or, you use addition, because I mean, if or qualifies what you're trying to explain, then you use addition, which is correct. And if and better qualifies what you're trying to explain, you use multiplication. All right, so it's a rule you could hold on to as a student. All right, so for red balls, the probability that the first time you draw a red ball will be 5 out of 9. Now remember, this is with replacement, so that means that the red ball you took, you put it back. All right, that means that the total structure of, you know, distribution and of the balls will remain the same throughout. Okay, so this 5 out of 9. Then for the blue balls, that would now be 4 out of 9, right? Because total number of balls not changed, number of red or blue balls not changed, because after they drew it, they replaced it back. All right, so we just multiply this, and this gives us 20 out of 81. That's option B. Okay, question 5. A bag contains 6 red, black, and green identical balls. A ball is picked and replaced. The table shows the result of 100 trials. Find the experimental probability of picking a green. Okay, so that would just be, green over total, right? Probability of green would be the number of green which you have, which is 16, right, over the total, which is 100. So I can divide by 4, yeah? That would be 4 over 25. 4 out of 25. That's option D. Question 6. All right, so question 6. A ball contains 3 red, 4 black, and 5 green balls. All right, so let me draw that. 3 red, four black, and 5 green balls. Right, so 2 balls are picked at random, one after the other without replacement. 2 balls are picked at random, one after the other without replacement. Find the possibility that one is red and the other is green. So the possibility that one is red and the other is green. So that means there are 2 ways this can happen, right? You could have red and then green, or you could have green and then red. So there's no, the order is not fixed. They didn't say find the possibility that the first is red and the second is green. No, they just said find the possibility that one is red and the other is green. Okay, so the possibility of the first one being red, of course, that would be 3 out of 12, right? Then times, now for the second one being green, because we have taken out one red, so the setup has changed, right? So this will now be 5 out of 11, then plus let me put the red ball back, please. Okay, now for the second possibility we are considering, right, probability of the first one being green would be 5 over 12. All right, by the time I take off one green ball, the possibility of the second one being red would now be what? 3 out of 11. Okay, so here 1, here 4 gives me 5 over 44, plus same here 1, here 4 gives 5 over 44, so which gives me 10 over 44, which is 5 over 22. All right, that's option B. So I mean, again, you could just say the possibility of both of them would be twice the first one. All right, or in further maths, you know, if when you do combination and permutation, right, it would be 2 factorial times the possibility of just the first one. Right, possibility of the first one. Okay, but I guess this method is fine because it's intuitive. You don't have to do anything else. Just go red, green, or green, red. You really just need to remember that the you know, you're looking at the possibility that one is red and the other is green, and there are 2 ways that can happen. There are 2 ways that can happen. All right, so question 7. A bag contains 4 white marbles and 3 blue marbles. Another bag contains 5 red and 6 blue marbles. If a marble is picked at random from each bag, find the probability that they are of the same color. Okay, so the only way we can have, I mean, you can think of the questions for a bit, right? But the only way you can have the same color is if you have, blue and blue. All right, so that means you are really looking at probability of finding blue in the first bag, right? Then times the probability of finding blue in the second bag, because you can't have white and white because there's no white in the second one, right? You can't have red and red because there's no red. So probability of finding blue in the first one will just be 3 over 7. And probability of finding blue in the second will be 6 over 11. All right, so that would be 18 out of 77. Right, that's option D. All right, question 8. A box contains 12 identical balls, of which 5 are red, 4 are blue, and the rest are green. Okay, so we have, let me draw this out. So 5 are red. Obviously there will be just 3 green balls, right? So 5 are red. Four are blue. And the rest are green. So the rest will just be 3, right? Because total is 12. Okay, so we are drawing with replacement. Find the probability that both of them are red. All right, so that will be probability that will be 5 over 12 the first time. Then for the second trial, so because you replace the red, that means the total number of balls will be the same. Total number of red balls will be the same, right? So times 5 over 12 again. which just give you 25 over 144. All right, that's option D. 25 over 144. So a box contains 2 white and 3 blue identical balls. All right, so let's draw it out. We have 2 white and then 3 blue identical balls. If 2 balls are picked at random, one after the other without replacement, what's the probability of picking 2 balls of different colors? All right, so there are 2 ways this can happen, right? If you're going to pick 2 balls of different colors, then it's either you pick a white and then a blue, or what? You pick a blue and then a white. Now remember, it's without replacement, so that means that the setup of the balls would be changing. All right, it would be changing. So let's see. Probably you're picking a white ball the first time will be 2 out of 5. So I'll take out a white ball, and the probability of picking a blue ball now would be 3 out of 4. All right, now plus, so let's go do the second iteration, right? So probability of picking a blue ball is 3 out of 5. All right, now let me take out the blue ball we just picked because it's without replacement, and probability of picking a white ball now becomes 2 out of 4. So let's solve this. Here 1, here 2, we end up with 3 out of 10 plus, yes, that's 3 out of 10. Here 1, here 2, we end up with 3 out of 10 again, which kind of gives us 3 plus 3, that's 6 out of 20, which is 6 out of 10. 6 out of 10. 6 out of 10, which is 3 out of 5. All right, that's option C. All right, that's for question 9. Question 10. A box contains 2 white and 3 blue identical marbles. If 2 marbles are picked at random, one after the other without replacement, what's the probability of picking 2 marbles of different colors? 2 white and 3 blue identical marbles. Let me draw that. 2 white and then 3 blue identical marbles. All right, if 2 marbles are picked at random, one after the other without replacement, what's the probability of picking 2 marbles of different colors? So there are 2 ways this can happen. You could pick a white and then you pick a blue, or you could pick a blue and then you pick a white. All right, now remember, it's without replacement. That means the setup of the balls will be changing, so you need to be very careful. So just track with me. Probability of picking a white the first time will be 2 out of 5. Now, but then for the second time, if you're going to, for the second, when you're trying the second one, if you're going to pick a blue, what you have then would now be 3 out of 4 plus probability of picking a blue. So let me return the white ball so that we can do the second iteration, second draw. All right, so probability of picking a blue now would be 3 out of 5 again, times probability of picking a white. Because we picked a blue, I'll take that blue out. It will now be 2 out of 4. Okay, so if I do the division, is going to be 2 here 1, 2 here 2, 2 here 1, 2 here 2. So we're going to have 3 out of 10 plus 3 out of 10, which gives 6 out of 10, or better still, 3 out of 5. So the correct option here is option B. Right, so I think it was the same question with the previous one. Okay, next page. Okay, so a box contains 40 identical balls, of which 10 are red and 12 are blue. If a ball is selected at random from the box, what's probably that it is neither red nor blue? So we want everything else in the box apart from the red and blue balls, right? So So how many balls are not red or blue? All right, so if we do that, that would be 40 minus 10 plus 12. Okay, that's 40 minus 22. That's 28. So there are 28 balls that falls into the category, right? So the probability of picking any of those balls would be, the probability would be 28 out of 40, which would be, which would be, I can divide by 4, right? That's 7 out of 10. Oh, sorry. It's supposed to be 18 balls. All right, so it's supposed to be 18 balls. So 18 balls. So 18 out of 40 is, I can divide by 2, right? That would be 9. 9 out of 20. Yes, that's option A. Okay, so and there's another way to do this, right? You could also do, because probability of not something, right? Probability of not these two options, right, would be 1 minus probability of either of them. All right, so I can say probability of not red or blue will be equal to 1 minus probability of what? Red or blue. That will be 1 minus, what's probability of red or blue? That will be 10 over 40 plus 12 over 40. That will be 1 minus 22 over 40. I can rewrite 1 as 40 over 40, right? Minus 22 over 40, which gives 18 over 40, which gives 9 over 20. Okay, so whichever one you're good with is fine. I mean, it's cool to know both of them. The first one is more intuitive, all right, but the second one is more proper, I guess. You know, it at least it uses a another rule, you know, in solve it. So I guess, but either one is fine. Okay, 12 says a box contains 5 red, 3 green, and 4 blue balls. A boy is allowed to take away 2 balls from the box. What's probability that the 2 balls are red? Okay, so again, the fact that it's allowed to take away, that means he didn't return it. So you could just write this as without replacement. Okay, so it means that it was without replacement, right? So take away 2 balls from the box. Both of them are red. All right, so that will be the probability that the first one is red times probably the second one is red. So let me draw this out. We have red. We have 5 red. 1, 2, 3, 4, 5. We have 3 green. 1, 2, 3, and then we have 4 blue. 1, 2, 3, 4. Find the probability that 2 balls are red. Okay, so the probability that the first one is red would be 5 out of, how many balls are there in total now? We have 12, right? So times, remember the first ball we took away was red, right? So the probability that the second one is also red would be, now we have just 4 red balls left out of 11. So we're looking at 9 out of 9. 12 times 11 is 132. Right? I think we can reduce this. Oh yes, we could have. Sorry, let me just do it here before I got here. So here will be 1, 4 here, 1, 4 in this is 3, right? So the answer is 5 out of 33. So it's easier that way. 5 out of 33. Okay, a ball contains 5 red, red, 5 red. So okay, so 5 red. 1, 2, 3, 4, 5. 3 green. And then 4 blue. Okay, so a boy is allowed to take away 2 balls. So this takeaway here means without replacement, right? The fact that it's allowed to take it away means that it's without replacement. So find probability that one is green and the other is blue. All right, so there are 2 ways this can happen. It's either he first takes away a green, then a blue, or he takes away a blue, then a green. Okay, so let's go with the first one. Probability of taking away a green, then a blue. Green would be, that would be 3 out of 12, right? Times, now, we've taken away a green. The probability of taking a blue will be 4 out of 11, all right? 4 out of 11, because the blue is 4, but the total number of balls has dropped to 11. Or, so let me put the blue ball back, right, before I consider the other possibility. I'm sorry, the green ball back. Now, probability of taking the blue first would be, yes, 4 out of 12. Then probability of taking a green now. So let me take out that blue that we've taken out. Probability of taking a green would now be 3 out of 11. Okay, so we can calculate this. I can cancel this 2 and then cancel out the 12, because 3 times so that means the first one is 1 out of 11. Same thing, I can cancel this 2 and then cancel out the 12, right? So plus 1 out of 11, which gives me 2 out of 11, right? 2 out of 11. That's option C. Okay, so a box contains black, white, and red identical balls. The probability of picking a white ball, a black ball at random, is 3 out of 10. Probability of picking a white ball at random is 3 out of 5. If there are 30 balls in the box, how many of them are red? If there are 30 balls in the box, how many of them are red? So there's 3 out of 10 so if the probability of picking white balls, black ball, is 3 out of 10, that means that there have to be 9 black balls, right? Because think about it. So you can say 3 out of 10 is equal to x out of 30. All right, so this is for black. If I cross multiply this, I would have 90 is equal to 10x. That means that would make x what? 10. x9 rather, right? So there are 9 black balls and 9. All right, and then now for the so that's 9 black balls. Now, if you do the same thing for the white ball, probability of picking a white ball would be number of white balls, right? X over 30. And then they're telling that the answer to that is 3 out of 5. So we can just cross multiply this, right? So we'd have 5x is equal to 90. That means x is 18. All right, so that means there are 18 white balls. So what's left for red? Well, the red balls would just be 3. We'd have 3 red balls. All right, so we'll have 3 red balls because they have to total 30, right? So they have 3 red balls. All right. Alternatively, another way you could have done this is you could have said that the probability of picking a white ball, all right, probability of picking a white ball, probability of picking a red ball would be equal to 1 minus probability of picking a white plus probability of picking a black, right? Because that's the only thing that is left. So probability of picking a red would be 1 minus white is 3 out of 10. Oh, white is 3 out of 5 plus 3 out of 10 for black, right? So that will be 1 minus, if I add this up, I would have out of 10, I would have 6 plus 3, which would be 1 minus 9 over 10, which just gives me 1 over 10, right? So the probability of red is 1 out of 10. Yeah? Okay, so here we go. 1 out of 10, that probability would be equal to x. Now, x represents the amount of red balls, right? Red out of 30. So if I cross multiply this, I would have 10x is equal to 30 and x is equal to 3. So either method is fine. All right, either method is fine. Okay, so question 15, let's go. A box contains 12 identical balls. 5 are red, 4 are blue, and the rest are green. 12 identical balls. Five are red, 4 are blue, and the rest are green. Okay, so let me draw this out, okay? We have 5 red. 1, 2, 3, 4, 5. We have 4 blue. 1, 2, 3, 4. And the green, we have 3 green. If a ball is selected at random from the box, what's the probability that it is green? Right, so at random from the box, what's the probability that it is green? So the probability of green will just be the number of green balls, which is 3, over the total number of balls. Yes, 3 green balls over the total number of balls. The total number of balls is 12, right? That would be 1 out of 4. That's C. All right, 16. A box contains 2 white and 3 blue balls. If 2 balls are picked at random from the box one after the other with replacement, what's the probability that they are of different colors? Okay, so 2 white and 3 blue. So 2 white and 3 blue. All right, so the deal is that if it's with replacement, that means that the one you took, you put back. That means that the number of the set of balls, the system of the balls will remain the same. It will always be 2 red and 3 blue to draw from. All right, probably that they are of different colors. There are 2 ways it can happen. It's either you have a white and then a blue, or you have a blue first and then a white. So first scenario, probability of drawing a white is 2 out of 5. Probability of drawing a blue, because you replace the blue, the system remains the same, right? So the probability of drawing a blue would be 3 out of 5. Plus, probability of drawing a blue is 3 out of 5. Probability of drawing a white is 2 out of 5. Yes, so this will become 6 out of 25 plus 6 out of 25, which gives us 12 out of 25. Okay, a ball contains 5 red, 6 green, and 7 yellow pencils of the same size. What's probability of picking a green pencil at random? So probability of green would just be green over total, right? Which would be 6 out of 18, which is 1 in 3. 1 in 3. That's option B. A dice with faces numbered 1 to 6 is rolled once. What's probability of obtaining 3 or 4? All right. So probability of obtaining 3 plus probability of obtaining 4. Probability of obtaining 3 is 1 out of 6, because I mean there's only one side that has a 3 out of 6 of them. Plus probability of obtaining 4 is also 1 out of 6. So we end up with 2 out of 6, which is what? 1 in 3. That's option A. Number 19. A die is rolled 200 times. The outcomes obtained are shown in the table. Find the probability of obtaining a 2. All right. So probability of obtaining a 2 Well, that would be, no, the number of times you obtain the 2 over the total. All right, that would be probability of obtaining a 2 would be, you had, 2 occurred 30 times over the total. Total is 200. That's 3 out of 20. I believe that gives you 0.15. 0.15. That's option A. Number 20. A die is rolled 200 times. The outcomes obtained are shown in the table. Find the probability of obtaining a number less than 3. A number less than 3. All right. So what qualifies as less than 3? 2 and 1. Okay, so 3 is not included because 3 is 3, not less than 3. So we are dealing with 55. All right. So the probability of, so that's okay, you could say probability of 1 plus probability of 2, right? Those are your possible options. That will be 25 over 200. Total is 200 plus 30 over 200. So that would be 55 over 200, 11 over 40. 10 is 0.25, so the correct answer has to be A, 0.275. So I mean, you could use a calculator for that. That's fine. That's question 20. Next page. All right, a fair coin is tossed 3 times. Find the probability of getting 2 heads and 1 tail. Okay, so for this, I'm going to draw the sample space. All right, I'm going to draw the sample space. So by first toss, you could have a head, a tail, or a head. But by the second toss, it could have become, of course, the first is a tail. We already have a tail here, right? So it could be tail, tail. The second will now be tail, tail, or tail head. That's from, this first, space, right? But from the second one here, you could have a head and then a tail, or a head and then a head. All right. Then now, so this is for the second toss. So for the second toss, you have 4 possibilities: tail, 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 head, head, tail, head, head. Now for the third toss, we're going to do the same thing. I could have head, head, tail, or head, head, head. For this one here, the next one, I could have head, tail, head, or head, tail, tail. For the next one here, I could have tail, head, head, or tail, head, tail. And for the final one here, I could have tail, tail, head, or tail, tail, tail. So the question says, so this is sample space. So any question that concerns, a fair coin being tossed 3 times, this is the sample space. You can always draw it, and then we can now, decide from there. Okay, so 2 heads and 1 tail. This qualifies 1. This qualifies 2. Oh, sorry, 2 heads and 1 tail. I think I did 2 tails. Yes, I think I did 2 tails. And okay, so 2 heads and 1 tail. This qualifies. This qualifies. And this qualifies. So that's 3. All right, so we have 3 that qualify. 3 that have 2 heads and 1 tail, right? So that's 3 out of 8, because there are 8 possibilities. That's option A. If fair dice is rolled once, what's probability of obtaining a number less than 3? So numbers less than 3 on the die, you can either have 1 or 2. So probability of obtaining a 1 is 1 in 6. Probability of obtaining a 2 is also 1 in 6. All right, so that would be 2 out of 6, which is a 1 out of 3. So there's a 1 in 3 chance that you get a number less than 3. If fair die is rolled once, what's probability of obtaining a 4 and a 6? Okay, so there has to be something wrong with this question. Yes, it should be all right. This should be of obtaining, because if it's and, then that means it's not one you rolled it, right? Because that means you have to have rolled it the first time and then the second time. So we have to change this here to or. Okay, so obtaining a 4 or a 6. That means it's one single event, but then you have multiple outcomes, multiple possible outcomes that would be favorable. All right, so that'll be probability of obtaining a 4 plus the probability of obtaining a 6. Probability of obtaining a 4 is 1 in 6, plus probability of obtaining a 6 is 1 in 6 also. So our answer is 2 out of 6, or, well, 1 out of 3. That's option C. If fair die is thrown 2 times, what's the probability that the sum of the score is at least 10? All right, so you have to draw a very large sample space, but I'll try to do it fast. Let's do this quickly. So this is a sample space for throwing 2. So the first one, 1, 2, 3, 4, 5, 6. The second one, 1, 2, 3, 4, 5, 6. Perfect. All right. So we'll write the sum in, and then that sum will be able to tell, so so if I throw a 1 and a 1, that means the sum is 2. If I throw a 1 and a 2, the sum is 3, like that. 4, 5, 6, 7. You should try this, right? If I throw a 1 and a 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 11, 10, 9, 8, 7. So you can just play around with it, right? 4, 5, 6. 3 plus 2 is what? Yeah, 5. Okay, so 5, 6, 7, 6, 7, 8, 7, 8, 9, 8, 9, 10. Okay, so we're done. So you notice that the diagonals, each diagonal has the same sum, right? But we're looking at, now, what's the total sample space is 36. All right, that's 6 by 6, all right? And you could also count the black, yeah? But the probability that fits, okay, so of at least 10. At least 10 means 10 and greater, right? So that's, we're going to have 1, 2, 3, 4, 5, 6. So there's 6 ways that could happen, which means probability is 3 out of 36, 6 out of 36, or 1 out of 6. That's option D. Okay, question 25. If fair die is tossed once, what's probability of obtaining neither 5 nor 2? All right, so we don't want 5, we don't want 2, right? So that will be 1 minus the probability of obtaining 5 plus the probability of obtaining 2, right? So we get the probability of obtaining both of them, and we subtract that from 1. So that will be 1 minus, probability of obtaining a 5 is 1 over 6 plus 1 over 6, which is going to be 1 minus 2 over 6, which gives me 4 out of 6, right? Or 2 out of 3. All right, or 2 out of 3. Okay, so a group of 11 people can speak either French or English, or both. 7 can speak English, 6 can speak French. What's probably the person choosing at random can speak both English and French? Okay. Okay. So I could explain this using like a set, a set theory, right? So you have people that can speak French, people that can speak English, and then both of them, right? So the idea is that the total probability will be 1, all right? And you notice that this guy here is in both of them. So that means that the way you set this up is you would say 1 total probability set will be equal to probability of French plus probability of English minus probability of what? Both French and English. And you can think about it this way. This particular portion have shaded, right, which is the intersection, right, of both of them, those people actually occur both in French and in English. So that means that in adding just these two, you have added that part twice. So to get the actual total, you need to subtract it once. All right, because inside French, that portion is there. Inside English, that portion is also there. So to be fair, you have to subtract it once so that portion can happen just once. So that is either you will be adding something like this for French, and then for English, because you have subtracted this portion from English, then English will just be like this. So that way you would not have to have summed up this part twice. So this would be probability of French is 7/11, right? Okay, no, English is 7/11, sorry. French is 6/11, plus English is 7/11, then minus the both of them, right? So minus probability of French and English. So this would mean 1 is equal to 13/11 minus what? French, English, both of them. So this tells me that probability of French and English together would just be what? 2/11. All right, would just be 2/11. That's C. Okay. 28 says, what's probability that a letter is chosen from the letters of the English alphabet? What's probability that letter is from the word mathematics? So, of course, the number of letters in the English alphabet is 26. So the desirable is that it comes from the word mathematics, right? So let's count the number of unique letters in the word mathematics. So 1, 2, 3, 4, 5. This has happened before. This has happened before. This has happened before. Okay, we can take 6, 7, 8. So it's 8 out of 26, which I can reduce to what? 4 out of 13. All right, that's option A. Okay, 26 says, a local community has 2 newspapers, the Morning Times and the Evening Dispatch. The Morning Times is read by 45% of household and Evening Dispatch by 60% of household. If 20% of household read both papers, find the probability that a particular household reads at least one paper. Okay, so I'm going to just draw a set. All right, I'm just going to draw a set. Yeah. Sorry. So we are told that MT, meaning Morning Times, and Evening Dispatch is ED. So MT is 45 and ED is 60%. All right. And we are told that 20% read both. So that means that the people that read only MT would be 45 minus 20, right? 45% minus 20%, leaving me with 25%. And people that reads only ED would be 60 minus 20%, giving me what? 40%. The reason why is that the 20% occurs in both of them. So to find the section that is, only empty, you have to do total of 45% minus the ones that read both of them. So this gives us a clearer picture of the description. And now we're asked to find the probability that a particular household reads at least one paper. All right. So that would be that you read at least one paper means those that read only MT, those that read both of them, and those that read only ED. Because at least one means one or more, right? So that would be 20 plus 25 plus 40. That's 85%, or what? 0.85. So 0.85. That's C. All right, number 30 says, a number is chosen at random from the set. What's probability that the number is greater than or equal to 7? All right, greater than or equal to 7. So we have the set of numbers from 1 to 10, which if you count them, they're actually 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 of them, right? So the total set is 10. The probability that the number is greater than or equal to 7, what numbers qualify? 7, 8, 9, 10. So that's 4. All right, so 4 in 10, which when you read it, you get 2 out of 5. The correct option is D. Okay, so a number is selected at random from the set. All right, so 18 to 29. Find probability that the number is prime. Okay, so I'll write out everything and we can just pick out the prime numbers, right? So we have 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So the number is prime. So what numbers are prime? 19 is prime. 23 is prime. 29 is prime. So that's 3. 3 out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 out of 12. Okay, that's 1 in 4. All right, so so that's 1 in 4. That's A. Now some people could have easily taken 3 out of 11, and the reason why you'll be wrong is because there are actually 12 numbers in the set. But if you just did 29 minus 18 to get the number of digits in the set, so the number of the number of terms or the number of numbers in the set, you will be wrong because that would give you 11. But when you count, it's actually going to give you 12. All right, so it's actually that difference plus 1. The range plus 1 will give you the actual number of numbers in the set. All right, so let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the correct answer is 1 out of 4. A. All right. So a number is selected at random from 40 to 50 inclusive. That means that 40 and 50 are included. Find the probability that the number is prime. So let's do that. So we have 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So let me put those down. We have 47, 43, and 41. Those are the 3 prime numbers. So there are 3 prime numbers there, and the set is 11. Right? If you count them, there are 11 digits between 40 and 50 included. Right, so 3 out of 11. So a survey shows that 28% of all men in the village wear size 9. What's probably that a man selected at random in the village wears size 9? So that's just, that's that 28 over 100. All right. So that 28 over 100. So that would be 7 out of 25 when you divide by 4. So that's option A. Grade 4. Find probability that a number selected at random between 30 and 50 is prime. Okay, so 30 to 50 inclusive. So let me write it out. 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, and 50. Now, if you look at this, right, you might wonder that, oh, maybe, there are supposed to be 20 numbers in the set. No, there are actually 21 numbers in the set. Right, and you can count them, you would see. You can just pause the video and count them, you would see. So, why is it 21? Because 30 and 50 are included. So when you count, right, the number of items in the set would actually be n plus 1, or the range plus 1. All right, so don't just subtract and write 20. All right, you'll be wrong. You can pause it and count it to see. Okay, now let's look at the prime numbers. So the prime numbers we have here, we have 1, 2, 3, 4, 5. I think that was all 5. All right, so 5 out of 21. So that's option D. So 35 says, from a box containing 2 red, 6 white, and 5 black balls, a ball is randomly selected. What's probably that the selected ball is black? Because there are 5 black balls there, right? So that's probability of black. Okay, so let me draw this. We have 2 red, 6 white, and 5 black. So that would be 5, the 5 black out of the total number, which is, oh, 6 white. I'm sorry. I drew 3 white, so 6 white. Oh, okay, let me just draw the other white here, right? So that's 6 white. That'll be 5 out of, so let's count them all now. That'll be 5 plus 5 is 10, 10 plus 3. So that's 5 out of 13. Right, so 5 out of 13, sorry. Okay, so a number is selected from the set. Find probability that it is a rational number. All right, so rational numbers are numbers that can be written as fractions, right? So they are not surds. So any number that cannot be simplified to a surd is that cannot be simplified to, you know, a fraction, all right, or a whole number is not a rational number. So like root 2, this is not a rational number. This is not a rational number. This is a rational number because it is 3, right? And this is not a rational number. So how many rational numbers do we have there? All right, we have 2. So that's 2 in 1, 2, 3, 4, 5. So 2 in 5, that's C. Option C is correct. All right, so we go on to question 37. Okay, so question 37, it says, we're given the set A and B. If a number is picked at random from each of the 2 sets, what is the probability that the difference is 6 or 7? Okay, so the best way to work around this is to do a sample space, right? So we'll set up a sample space where we will just draw out all the possible, you know, differences, and then we'll now check out to see what the probability actually is. Okay, so the way we draw this is, on top we'll write out you know, all the possible, you know, values at A. That's 2, 4, 6, 8, and on the side we'll write out all the possible values of B. That's 2, 3, 5, 9. Okay, so this way we can now subtract. So let's subtract to see, you know, so we'll take the positive difference. Okay, so the difference between 2 and 2 is 0, between 4 and 2 is 2, between 6 and 2 is 4, and between 8 and 2 is 6. Difference between 2 and 3 is 1, 1, 3, 5. This is 3, 1, 1, 3. Then this is 7, 5, 3, and 1. Okay, so in total we have is 16, right? The total is 16, but the desired, all right, those of them that have a difference of 6 or 7, you would only find that here and here, right? So it's 2 out of 16, better written as what? 1 out of 8. Okay, so we just drew the sample space for the difference between the 2 sets, and we're able to easily see what the correct option is. All right, so question 38 is something similar. We're asked to find the probability that their product is odd. So find the probability that the product is odd. Okay, so we're given 2 sets, and the way we'll do this is we draw a sample space. Okay, so let's draw a sample space. and here I have 2, 4, 6, 8, and then for the other one, I'll write the other one on the side here. I have 2, 3, 5, and 9. Okay, so that's the sample space 2, 3, 5, and 9. All right, so that here in the middle here, I can now put in the values, right? I can now put in the values, the products, all right? So we can check for the odd products. So here's 4, here is 8, here is 12, and here is 16, 6, 12, 18, 24, 10, 20, 30, 40, 18, 36, 54, and 72. All right, so the probability that the product is odd. So we have the product here and there is no odd number, right? So it's actually 0 out of 16, right? Because there's no possible odd number, in that particular, that, like, considering both of these for the set. So it's 0 out of a total of 16. Okay. Okay. A number is selected at random from set B. All right, so we just have 4 numbers here, right, from set B. What probability that the number is prime? What prime numbers do we have? We have 2, 3, and 5. They are prime numbers, right? So that's 3 out of 4. So they are out of the 4 possible numbers in set B. 3 of them are prime. So the probability is 3 in 4. Okay, question 40. A number is chosen at random from the set. Find the probability that the number is a multiple of 3 or a multiple of 4. All right. So we are looking for the probability of 3 or 4. All right. Now, this is a case of a it's not mutually exclusive. Because a number can both be, a multiple of 3 and 4, right? So it's going to probability of 3 plus probability of 4 minus probability of 3 and 4. All right. So let me set up the numbers, right? Now, when I'm writing the numbers that make up the set, I am going to have to add 4 and 5 because it says less than or equal to. That means, 4 and 15. That means 4 and 15 are included in the set. So it's going to be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the probability of that is a multiple of 3, where do we have that? Probably there's a multiple of 3. We have 1, 2, 3, 4. So it's 4 out of 12. Plus, probably there's a multiple of 4. Where do we have those? We have that here. 1, 2. All right, so that's 2 out of 12. But then we have to subtract that probability that is a multiple of both 3 and 4, which occurs just once, right? So we'll have, multiple of 4 is actually, there are 3 of them. Sorry, so it's, multiple of 4. 4 is a multiple of 4, my bad. So this is 3, right? Okay, so the multiples of 4 are 3, 4, 8, and 12. Okay, so minus 1 out of 12. So that would be 7 out of 12 minus 1 out of 12, which gives you what? 6 out of 12, or you can write it as 1 out of 2. Right? 1 out of 2. Okay. Question 41. If a number is selected at random from each set of that and the other set of that, find the probability that the sum of the numbers is prime. Okay, so for this, I will just drop a sample space. All right, it's easier to drop a sample space. So and then I'll add them all up. So I'll have 1, 2, and 3. Then on the other hand, I have 2, 3, and 5. So let's get the sum. 1 plus 2 is 3, 4, 5. This is 4, 5, 6. This is 6, 7, 8. All right. So these are my actual samples, right? The ones I'm rewriting. The other ones are just the numbers on the edge. All right, so find the probability that the sum is prime. So what I have here is the sample space of the sum of the sum of the possible sums, sorry, of digits selected from both of them. So what's the probability that the sum is prime? So we have this is prime, this is prime, this is prime, and this is prime. So we have 4 of those, right? So 4 out of 9. 4 out of 9. So that's option A. Okay, find probably that the sum of the numbers is prime. Okay, so we just, we just did that. So yes, 4 over 9, yes. Okay. Okay, so question 43. Events X and Y are mutually exclusive. The probability of X is 1 over 3 and the probability of Y is 2 over 5. What's the probability of X intersection Y? All right, so the idea of mutual exclusivity means that both events cannot occur at the same time. That means that if I represent it using a set, this is one and this is the second one. This is X and this is Y. They can never occur at the same time. So that means that the probability of an intersection or the intersection would be an empty set D. The intersection would be an empty set D. All right. So mutually exclusive means that they cannot occur at the same time. Them happening mutually is exclusive. All right. So they are mutually exclusive of each other. All right. So they can't happen at the same time. So if you draw it in a set, you can see that, it's empty. It can never be, doesn't exist. Okay. So this says, again, they are mutually exclusive. Now, what's the union of both of them? All right, what's the union of both of them? So again, I would draw this using a set. So this space here means X, and this space here means Y. All right, remember they are mutually exclusive. All right, so because they are mutually exclusive, it means that there would be no region of overlap. All right, they can't happen at the same time. So the probability of the first one is 1 out of 3. Probability of the second one is 2 out of 5. So the probability of both of them, right, A union B, you just add them up. All right, it's just going to be 1 out of 3 plus 2 out of 5. So this gives me 15 here. 15 divided by 3 is 5. 5 times 1 is 5 plus 3 is 6. All right, so that's 11 out of 15. All right, so that's the union of both of them. Now, if there was an overlap, right, then you would have had to use, a slightly different formula, but because they are not overlapping, you just add them up. So the answer is 11 out of 15. So mutually exclusive means that they cannot occur at the same time, right? And that influenced, our decision. So the next one says, if the probability of an event occurring is X, what's the probability of the event not occurring? All right, so basically, what's the probability of the complement? All right, so all probability adds up to 1. All right, if it's happening or not happening, they add up to 1. Right, so that means that if the probability of an event occurring is X, all right, so this is probability of occurring, and then not occurring, all right, which is the only other option would be Y, right? So let me call that Y. This is not occurring. It must add up to 1. So that means that probability of it not occurring Y will be equal to 1 minus X. All right. So and it's an intuitive idea, right? One you have to hold on to. So if I have let me use something, I have right, so I have 3 red balls and 2 black balls, right? What's probability of picking a black ball? That is 2 out of 5. Probability of not picking a black ball, it means I'm going to pick a red ball, right? And that would be 3 out of 5. If you add both of them, what does that give you? 1. 5 out of 5, which is 1. So probability of something happening and something not happening, as long as those are the only two options, all right, then the summation of both of them would be 1. Okay, so the answer is 1 minus x. That's option B. 46 says, if the probability that an event will occur is P and the probability that it will not occur is Q, which of the following is true? All right, which of the following is true? So, well, that's going to mean by that P plus Q, the correct answer is P plus Q must equal 1. All right, because one of them must happen. So certainty is 1. All right, that's 1. And you must be sure that it's either the first one or the second one. It's either it happens or it doesn't happen. It's either it happens or it doesn't happen. So you could just skip back like a minute, right, to the previous question where, you know, I also answered something similar, right, and did an explanation drawing balls and all that. You know, the correct answer is B. All right, probability it occurs or not occur must be, it is certain that one of them must happen. All right, so it's like okay, let me use like an easy example, right? Probability of, so someone is going to have a child, all right? Probability of having a boy or not having a boy must be 1 because you're going to have a child, right? So as long as it's successful, right, delivery is successful, probability of having a boy plus probability of not boy must be 1. All right, there's a 100% chance that if it's not a boy, you are not going to have, you would have a girl. All right, you could also say probability of boy plus probability of girl would be 1. All right, so that's, let's move on. 47. So in a class of 45 students, 28 offer chemistry, 25 offer biology. If each student offers at least one of the two subjects, calculate the probability that a student selected at random from the class offers only chemistry. Okay, so the way I'll approach this problem is I'll draw a set, you know, like a Venn diagram. All right, so the total would be for the class, and that would be 45. And then I would have chemistry and biology. So this is C for chemistry, all right, and B for biology. Okay, so it's a non-mutually exclusive, you know, both events are non-mutually exclusive because they can occur at the same time, right? It's possible to offer both chemistry and biology. So that means that, but total for chemistry is 28, total for biology is 25. And then not offering any of them is 0, all right? Because we are told that each student offers at least one of the two subjects. Okay, so I can call both of them for now X. All right, that will now mean that the number of students that offer chemistry alone will be 28 minus X. And the number of students that offer biology alone will be 25 minus X. So we can total all of that, right? We can say 28 plus X, 28 minus X plus 25 minus X is equal to 45. So that gives minus X cancels out plus X, right? So I would have 53 minus X giving me 45, which means that X would be 53 minus 45. That's going to be 8, right? X is going to be 8. So this means that 8 people do both subjects, right? So I'll just rewrite this, right? Put 8 there. And then for chemistry alone, would be 25 minus 8, which means that chemistry is actually just what? 20. Okay, so 20 people are taking chemistry. And then chemistry alone, that is, right? And then biology alone will be 25 minus 8, which is 17. All right, so the question, we cannot answer the question that says, probably that a student selected at random from the class offers chemistry only. So that would be 20 out of 45, right? Because chemistry only is 20, right? Which is 4 out of 9. All right, so that's option A. Okay, so in an athletics competition, the probability of an athlete wins a 100-meter race is 1/8, and the probability that he wins a high jump is 1/4. It's a quarter. What's the probability he wins only one of the events? Okay, so there are two ways that he can win only one of the events. All right, that means he has to win the first one and lose the second one, or lose the first one and win the second one. All right, so that'll be he wins the high jump. So let me see high jump win, and then race lose, plus the race win and he loses the high jump. All right, so these are the only two ways that he can fulfill this, winning only one of the events. So the probability of him winning the losing the race would be 7 out of 8, right? So that's 1 minus 1 out of 8, then times the probability of him winning the high jump is 1 out of 4, plus the probability of him winning the race is 1 out of 8, times the probability of him winning the high jump is losing the high jump rather is 3 out of 4. All right, so this would be 7 out of 32 plus 3 out of 32, which gives 10 out of 32, or 5 out of 16. All right, so that's one way. Another way we could do it is, to draw a Venn diagram. So let me draw a Venn diagram, because I find that this gives like an intuitive approach to things, right? So the answer is 5 out of 16. So we have, so let's have the race here, and here we'll have the jump. All right, and here we'll have the jump. So the probability of winning the race is 1 out of 4. Probability of winning the jump is 1 out of 8. Probability of winning both of them, all right, probability of winning both of them, they are independent events, so you can multiply them, right? Probability of winning the race and the jump is 1 out of 4 times 1 out of 8, which gives you 1 out of 32, right? That means what we have here in the middle is 1 out of 32. So this means that I can calculate the probability of just winning the race alone, right? So I can do 1 out of 4 minus 1 over 32. That will just give me this section here, all right, which is where I would win, the race alone, all right? And I can do the same for jump, do 1 out of 8 minus 1 over 32, and that will give me the probability of winning the jump alone, all right? So let's do that quickly. For the race alone would be 1 out of 4 minus 1 over 32, all right? That's going to be LCM of 32, so that's 8 minus 1, which gives me 7 out of 32. Then for the jump alone, all right, probability of winning the jump alone, that'll be 1 out of 8 minus 1 out of 32. LCM again is 32. That'll be 4 minus 1, which is 3 out of 32. All right, that's 3 out of 32. So for winning alone, one alone, right, it's here and here, all right, absent the intersection. So I'm going to have 7 out of 32 plus 3 out of 32, all right, adding those two up, which gives me 10 out of 32, or what, 5, better written as 5 out of 16. All right, that's option D. So either method works, and I think it's cool to, like, for people that are very good with sets, right? I mean, I feel like the drawing brings it to life also, and for people that are very logical, right, like the first method also works. So that's for number 48. So let's take on 49. 49 says that Mrs. Gabriel is pregnant. The probability that she will birth a girl is half. Probability that the baby will have blue eyes is a quarter. What's probability that she will give birth to a girl with blue eyes? Oh, all right. So okay, so the probability that she will give birth to a girl with blue eyes would mean that both would have to be true, right? So is probability of girl, all right, times the probability of blue eyes. All right, probability of girl times probability of, because there are two independent events that we're trying to see probability of them, both of them happening, right? So the girl, so it's going to be, it will be a girl and she would have, the baby will have blue eyes. So that will be 1 out of 2 times 1 out of 4. So there is a 1 in 8 chance that she would have a baby girl with blue eyes. Okay. Next is Mrs. Jones is expecting a baby. The probability that to be a boy is half, and the probability that the baby will have blue eyes is 1 out of 4. What's the probability that she'll have a blue-eyed boy? Okay, so this question was just repeated from the former, right? The probability that to be a boy is a blue-eyed boy. That means I want both events to occur simultaneously, right? So, and they are both independent events. So it's going to be probability of boy times the probability of it being, or the baby being, or having a blue eye, right? So this will be 1 out of 4 times 1 out of 2, giving 1 out of 8. All right, giving 1 out of 8. Okay, questions 51. Out of 60 members of an association, 15 are doctors, 9 are lawyers. If a member is selected at random from the association, what's the probability that the member is neither a doctor nor a lawyer? Okay, so we have to assume that, of course, there are no doctors that are also lawyers, right? So that would be weird, a very weird career choice. Doctor then lawyer. Okay, so 15 doctors. So the probability of a doctor would be 15 out of 60. And then the probability of a lawyer would be 9 out of 60, right? So the probability of neither, all right, the probability of neither will be 1 minus the probability of what? Either. All right, so that will be 1 minus 15 over 60 plus 9 over 60. That will be 1 minus 24 over 60, of which I can rewrite 1 as 60 over 60, right? Which gives me 36 over 60, or what? 3 out of 5. 3 out of 5. So the correct answer is 3 out of 5. All right. So there are multiple ways to have done it though, right? Because I've even just done the number of people that are not as doctors or lawyers. That will be 60 minus, of course, 15 plus 9, right? So that will just be 36. Then you could now say probability of neither, all right? Probability of these guys, right? Probability of neither. Probability of neither would just be 36 out of 60, which we can reduce to 3 out of 5. So either way is fine. All right, either way is fine. Okay, so the bar chart below shows the scores of some students in a test. If one student is selected at random, find the probability that he scored at most 2 marks. All right, so that means we need 2 marks and below. So the first thing you need to do is we need to know how many students are there in all. All right, so I assume that this is students and this is scores. All right, so total number of students would be 4 plus 2 plus 5 plus 6, right, and plus 3. So 4 plus 2 is 6, 6 plus 5 is 11, 11 plus 6 is 17, and 17 plus 3 is 20, right? So there are 20, all right, and yeah, the 20 students in all. So the probability that is scored at most 2 marks, that will be probability of scoring 0, but probability of scoring 2, probability of scoring 5. So that would be 11, all right? 11 over 20. There are 11 students that scored 2 marks or below. That's 11 out of 20. Okay, 53. The data shows the number of workers employed in the various sections of a construction company in Lagos. If one of the workers is absent on a certain day, what's the probability that he is a bricklayer? All right, so that would be, well, bricklayer out of the total, right? So that would be 18 out of the total. So we need to total this. So I need to total this. That would be 24 plus 12 plus 9 plus 18 plus 27 plus 15 plus 3. So 18 out of 108. Right? I can divide by 9, I'll get 2 out of 12, and then divide by 2 again, I'll get 1 in 6. So there's a 1 in 6 chance that the worker is a bricklayer. That's A. Okay. The data shows the number of workers employed in the various sections of a construction company in Lagos. If a worker is retrenched, what's probably that he's a plumber or a plasterer? All right, so that will be, or means, of course, we add, right? It means that it's a single event we're trying to check out, but then we have multiple outcomes now, so we add up, right? So that'll be probability of a plumber plus probability of a plasterer. All right, probability of it being a plumber would be 12 out of, well, if you sum up the total, you will get 108, plus probability of it being a plasterer, or a plasterer, I guess, that will be 15 out of 108. So when you add this up, you would get 27 out of 108, which I can divide by, I can divide by 27, right? I would get 1 out of 4. So there's a 1 in 4 chance that the person is either a plumber or a plasterer. All right, question 55. The number of goals scored by a school team in 10 netball matches as follows. Find the probability that in a match, the school team will score at most 8 goals. At most 8 goals. That's 8 goals and below, right? So how many matches fit that category? 1, 2, 3, 4, 5, 6, 7. So 7 matches fit that category out of a total of 10 matches. All right, so that's 7 out of 10. That's option B. 56. The pie chart shows a distribution of 4,320 students who graduated from 4 departments in the university. If a student is picked at random from the 4 departments, what's probability that he is not from the education department? All right. So interestingly, right, in this particular question, we really don't need this because we can just work with what we have here. The total number of students in this section is proportional to the angle in the pie chart anyway, right? So we could just go not in education department. The angle that represents not in education department would be 360 minus 108, right? So this is not in education, right? So when you divide that by the total angle 360, that would give you 360 minus 108 is 252 divided by 360, which we can reduce to 7 out of 10. All right, 7 out of 10. That's D. All right. Alternatively, you could also use the complement, right, or the negation. You could say not from the education department. So you could find the probability of education department. All right, and then now find the negation of that, not that, which would just be 1 minus that. So if we solve for education department, probability of being in education department will simply be 108 over 360. All right, which would give you 3 out of 10. So the probability of not education department would be 1 minus, probability of education department, which would just be 7 out of 10. All right, so the correct option is D. The probability of a boy passing English and mathematics are X and Y, respectively. Find the probability of the boy failing both tests. Find the probability of the boy failing both tests. So that will be the probability of failing the first one. All right. So probability of failing English, probability of failing English times the probability of failing maths. All right. So the probability of failing English is 1 minus X. And the probability of failing maths is 1 minus Y. Right. So if we expand this, we would have 1 times 1 is 1 minus Y minus X plus XY. All right. But I can factor out the minus sign from here. I have 1 minus brackets, what? X plus Y. Right. So we just took the probability of failing the first one times probability of him failing the second one. Okay. So 58 says probabilities that John and James passed an examination are 3 out of 4 and 3 out of 5. Find the probability of both boys failing the examination. So that means that John has to fail and then James has to also fail. All right. So that will be the probability of John failing times the probability of James failing. So this will be probability of John failing is 1 minus, probability of John failing is 1 minus probability of him passing, right? So this is 1 minus 3 out of 4 times probability of James failing is 1 minus 3 out of 5. So this will just leave us with 1 out of 4 times 2 out of 5, which gives us 2 out of 20. Can be simplified to 1 out of 10, right? So it can be simplified to 1 out of 10. All right, 59 says the probabilities that Keba, Abu, and Omar will hit a target are 2 out of 3, 3 out of 4, and 4 out of 5. Find the probability that only Keba will hit the target. All right, so that means the Keba, yes, we want Keba to pass, but then, or hit the target, but Abu and Omar, we need their negations, right? Because they have to fail. That's the only way only Keba will hit the target. All right, so we're going to have this probability, but then we're going to have the negation of this one and the negation of this one. All right, so the probability of, so that'll be the probability of Keba hitting times the probability of Abu not hitting times the probability of Omar not hitting. So probability of Keba hitting is 2 out of 3. Probability of Abu not hitting will be 1 minus probability of Abu actually hitting, right? So that'll be 1 minus 3 out of 4 times the probability of Omar not hitting would be 1 minus 4 out of 5. So this would be 2 out of 3 times what? 1 out of 4 times 1 out of 5, which gives you 2 out of 60 that can be reduced to what? 1 out of 30. That's option D. '60. The probabilities that Kojo and Adoga will pass an examination are 3 out of 5 and 3 out of 4 and 3 out of 5 respectively. Find the probability that of both boys failing the examination. So the probability of both boys failing the examination, that means that we need to find the probability of Kojo not passing and then the probability of Adoga not passing. So that will be probability of Kojo not passing would be 1 minus 3 over 4. All right, that's negation of Kojo passing. Times probability of Adoga not passing will be 1 minus 3 out of 5. So that will be 1 out of 4 times 2 out of 5, right? Which is 2 out of 20 that we can reduce to 1 out of 10. 1 out of 10, that's option D. All right. So the probability of an event P happening is 1 out of 5, and that of event Q is 1 out of 4. If the events are independent, what's the probability that neither of them happen? So one probability that neither of them happens. Okay, so that means that the first one doesn't happen, and then the second one does not happen, and they're independent events. All right. So it's going to be the probability of P not happening, that's negation of P, times the probability of what? Q not happening. So probability of P not happening is 1 minus 1 out of 5, times probability of Q not happening is 1 minus 1 out of 4. All right. So that will be 4 over 5 times 3 over 4, which gives us 3 out of 5. That's option C. All right, 62. The ratio of boys to girls in the class is 5 to 3. Find the probability of selecting a girl at random from the class. That will just be the ratio of girls. Again, we can do this because ratios are basically proportional to the total number, right? So that will be the probability of girls, or the number of girls. So the probability of a girl will be the number of girls over the total, right? What's the number of girls, or the ratio of the girls as it were? That's 3. And the total is what? 5 plus 3. So we end up with 3 out of 8. All right, so 3 out of 8. The table below gives the marks scored by a group of students in the test. What's probability of selecting a student from a group that scored a 2 or a 3? All right, so that will be the probability of selecting a student that scored 2 plus the probability of selecting a student that scored 3. So what probability of selecting a student that scored 2? That would be 7, right? 7 students scored 2 out of 22 in total, plus for 3, 5 students scored 3 out of 22 in total. So we're looking at 12 out of 22 that can be simplified to 6 out of 11. All right, so 6 out of 11. That's the correct option A. 64. The table below gives the scores of students, a group of students in an English test. If a student is chosen at random from the group, what probability that he scored at least 60 marks? At least 6 marks. All right, so at least 6 marks, what qualifies is students that scored 6 and those that scored 7. All right, for at least. So that would be probability of students that scored 6 plus probability of students that scored 7. All right, next we need to find out the total number of students. That's 2 plus 4, 6 plus 7, 13 plus 2, 15 plus 5, 20. All right, so for 6 is going to be, there are 3 students that scored 6 out of 20. Then for 7, there are 2 students that scored 7 out of 20. So we're looking at 5 out of 20, which simplifies to 1 out of 4. 1 out of 4, that's option B. All right, question 65. The table gives the distribution of outcomes obtained when a die was rolled 100 times. What is the experimental probability that it shows at most 4 when rolled again? When rolled again. So at most 4 means 4 and below, right? So we have to consider the experiment that was performed and check for that. So that would mean here, 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 here. The total number of outcomes, all right, that falls in that category would be 18 plus 14 plus 20 plus 16, then out of the total of 100 times, right? So let's calculate that. That's 14 plus 16 is 30, 30 plus 20 is 50, 50 plus 18 is 68. All right, so that's 68 out of 100, which I believe is divisible by 4. All right, that can be reduced to 17 out of 25. That's option D. All right, question 66. The table shows the distribution of goals scored by 25 teams in a football competition. Find the probability that the team selected at random scored at most 3 goals. At most 3 goals. All right, so that would fit in this category, and this category. All right, so the total number of teams is 25, but the number of teams that fit in the category, right, is, there are 10 of them. All right, so that's 3 plus 1 plus 6. So that number of teams, right, 10 teams fit in the category of those that scored at most 3 goals. So if I reduce this, I would have just 2 out of 5, right? So 2 out of 5 is the correct answer, A. All right, 67 says, the table shows the distribution of goals scored by 25 teams in a football competition. Find the probability that a team selected at random scored either 4 or 7 goals. All right, so that's the probability of that you pick a team that scored 4 plus the probability that you pick a team that scored what? 7. All right, so they are 25. So probability that it was a team that scored 4 is 6 over 25. All right, because there were 6 teams in that category, plus probability that you picked a team that scored 7 is 3 out of 25. So simplifying this, we arrive at 9 out of what? 25. That's option A. '68 says, the table shows the number of pets kept by 30 students in the class. If a student is picked at random from the class, what's the probability that this student has kept more than 1 pet? All right, so more than 1 pet fits into, well, 2 pets, 3 pets, or 4 pets. All right, 1 pet doesn't fit into more than 1 pet. All right, so that means that the total number of students is 30, but the number of students that fit into our selected category is 5 plus 10 plus 3, which gives 18 over 20, 18 over 30, which we can simplify dividing by 6 to 3 over 5. So there's a 3 in 5 chance that this student kept more than 1 pet. Question 69. There are M boys and 12 girls in the class. What's the probability of selecting at random a girl from the class? Probability of selecting a girl from the class, the desirable is 12, right? So there are 12 girls. So probability of a girl. So there are 12 girls over the total number, which will be what? M plus 12. So the correct option is option A. M over M plus 12. 12 over M plus 12 rather. Right? Question 70. There are 8 boys and 6 girls in the lift. What's the probability that the first person who steps out of the lift would be a boy? All right, so that's basically same thing as selecting at random, right? So probability of it being a boy. So we have 8 boys over the total. How many people are in the lift in total? 12. All right, so that would be, if I reduce that, I would have 2 out of 3. So there's a 2 in 3 chance that a boy will be the first to get out of the lift. Okay, question 71. 3 balls are drawn, one after the other with replacement, from a bag containing 5 red, 9 white, and 4 blue identical balls. All right, so what probability that there are 1 red, 1 white, and 1 blue in order? So we're trying to find the probability that we're going to draw red, then white, and then blue, right? So it's going to be a probability of drawing a red times probability of drawing a white times the probability of drawing a blue. Okay, so probability of drawing a red is 5 out of 18 times probability of drawing a white. Now, since it was replaced, that means that the distribution of the balls remains the same, right? So it's just going to be 9 out of 18. And for blue it's going to be 4 out of 18. All right, so that's the probability of red, white, blue in order. So I can cancel out. here 1, here 2, here 1, here 2, here 1, here 9. So my answer is 5 over 18 times 9 is 162. So 5 over 162, that's option D. 72 says 2 bottles are drawn with replacement from a crate containing 8 Coke, 12 Fanta, and 5 Sprite bottles. So 8 Coke, 12 Fanta, and 5 Sprite bottles. What's the probability that the first is Coke and the second is not Coke? Okay, so we want to have, now is with replacement, right? So that means that the total set will remain the same. So probably that the first is Coke is going to be 8 over 24, right? So this is Coke. Then times not Coke. Not Coke. Not Coke would be times 1 minus 8 over 24. All right, so that's a negation of Coke. So that will be 8 over 24 times, when you do this math, right, because that's 24 over 24 minus 8 over 24, right, that will be 16 over 24. So times 16 over 24. So multiply this out. Here will be 1, here will be 3, here will be 2, here will be 3. So I'm ending up with 2 out of 9. So there's a 2 out of 9 chance that the first one would be Coke and the second one will not be Coke. That's 72. 73 says 2 cards are drawn one after the other with replacement from a well shuffled ordinary pack of 52 cards containing 4 aces. Find the probability that they are both aces. Okay, so here is being replaced. That means what they took out, they put back. So the total number of cards remains 52. Total number of aces remains 4. All right, so we're going to have the probability of the first one will be 4 out of 52. Now, when you replace it and draw it again, chances of picking out another ace will be 4 out of what? 52. So we can cancel out here 1, here 13, here 1, here 13. So we end up with 1 in what? 169, right? So that's probability of 2 aces, right? That's probability of 2 aces. 1 in 169. Okay, 74. 2 fair dice are tossed together. What's the probability that the sum of the outcome is at least 10? Okay, so for this, we'll have to draw the sample space, right? We'll have to draw the sample space for sum of a pair of dice. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I need another one. That's 6. Okay, so that we can write out the sum. All right, the sum of everything. Okay, so you need to practice this yourself. All right, so here 1 plus, if I trade 1 and 1, here will be 2. If I trade 1 and 2, here will be 3. If I trade 1 and 3, here will be 4. So the sample space I'm drawing, right, is for the sum. All right, and you see it follows a pattern, an interesting pattern. The diagonals are all 7. All right, and then everything increases by 1, both left and up, sideways and up, down. Oh, my bad. I made a mistake. There's nothing here. All right, so there we go. Okay, so the probability that the sum is at least 10. At least 10 means 10 or more, right? So there are 36 possible options, right? If you count what we have here, right? 6 by 6. But the probability that we have at least 10 is here works 2, 3, 4, 5, 6. So that's 6 in 36. All right, so there are 6 of them that are at least 10 out of the 36 in total, making 1 in 6. All right, so the correct option is B. $75. If a student in favor of the proposal is selected for a post, so we have that, right? What's the probability that he is from group A? All right, a student selected in favor of the proposal is selected for a post. So that means it has to be someone from here, right? what's probability that is from group A? All right, so that'll be 128 over the total for those in favor is 128 plus 96. So let me do that on my calculator. All right, so I have 4 in, is a 4 in. Okay, so I got 4 in 7. $76. 2 groups of male students cast their vote on a particular proposal. The result are as follows. If a student is choosing at random, what probability that he is against the proposal? Okay, so that will be the total for against. All right, total for against. So let me draw that here. So this is 224 and this is 78. So of everybody, right, what's the probability that he is against the proposal? So that will be 78 out of the total. All right. If a student is at random, what probability that he is against the proposal? That should be 78 over the summation of both of them. So again, I would the correct answer is not there. I would edit one of the options to be the correct answer is 39 over 151. All right, so I'll edit one of the options to be that. Okay. All right, 77. Use the following information. The surnames of 40 children in the class are arranged in alphabetical order. 16 begin with O and 9 begin with A. 14 of the letters of the alphabet do not appear as a first letter of a surname. What's probability that the surname of a child picked at random from the class begins with either O or A? All right, so that will just be the probability of O plus probability of what? A. Probability of O is 16 out of 40 plus probability of A is 9 out of 40. So we end up with 25 out of 40 or 5 over 8. All right, so the correct option is A, 5 over 8. Yeah, I mean, because you can reduce this to here 5, here 8, right? That will be 5 out of 8. Question 78. What's the probability of having an even number in a single toss of a fair dice? Probability of having an even number is, I mean, that's either, so that would probability of having 2, sorry, my bad. Good. So that would be probability of having 2 plus probability of having the 4 plus probability of having the 6. Probability of having 2 is 1 out of 6 because there's only one 2, you know, there's only one side labeled 2, right? Same thing here. There's only one side labeled 4 plus same thing here, only one side labeled 6. So that would be 3 out of 6, which gives me what? A 1 out of 2. All right, so the correct option is D, 1 out of 2. All right, 78. What's the probability of having an odd number in a single toss of a fair die? All right, so in the die we have, you know, that would be probability of scoring a 1 plus probability of scoring a 3 plus probability of scoring a 5. Probability of scoring of that will be, this is 1 out of 6 plus this is 1 out of 6 again, and this is 1 out of 6 again, because there's only one side of the die, you know, that has 3. There's only one side of the die that has 5. All right, so each of them is just 1 out of 6, which gives you 3 out of 6, which gives you what? Half, 1 out of 2. All right, question 18. What's the probability of having an odd number in a single throw of a fair die with faces numbered 1, 2, 3, 4, 5, 6? Good. So, how many faces qualify as odd? That's 1, 3, and 5. right? So it's going to be probability of 1, of picking out a 1, but probability of picking out a 3, plus probability of picking out a 5. That will be 1 in 6 plus 1 in 6 plus 1 in 6, which gives us a 3 in 6, which can be simplified to what? 1 in 2. Okay, so the correct answer is 1 in 2. Okay, this says, what's the probability of throwing a number greater than 2 with a single fair die? What's the probability of throwing a number greater than 2 with a single fair die? So look at the numbers that work as, we have the options of throwing 1, 2, 3, 4, 5, 6, right? So these are the faces of a fair die. So a number greater than 2, what's qualified as number greater than 2? We have 3, 4, 5, and 6, right? So the probability of the desirable, right? Probability of greater than 2 is simply what? 4 out of what? 6. Oh, it can be simplified to 2 out of 3. All right, so 2 out of 3D. What's probability that 3 customers waiting in the bank will be served in the sequence of their arrival at the bank? What's the probability that 3 customers waiting in the bank will be served in the sequence of their arrival at the bank? Okay. So this probability, right, would be, well, there's only one way in order 1, 2, 3, right? But that would now be divided by the total number of ways that they can be served, all right? Which would be 3 factorial, all right? Because there are 3 ways you can call, so that would be 3 times 2 times 1. Because there are 3 ways you can call the first person, and once you've called the first person, then there'll be 2 ways you can call the second person, and of course, only 1 way you can call the third person, right? So this would just be 1 divided by 3 times 2 times 1, which is 1 over 6. All right, so factorial just means 3 times 2 times 1. All right, 7 factorial would mean 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, so yeah, the answer for this is 1 in 6. 84. What's the probability that a total sum of 7 would appear in 2 tosses of a fair dice? All right, so let's draw what that let's draw what 2 tosses would look like. So let's draw the sample space, that is. So at the top will represent, the possible for the first. At the side will represent the possible for the second, the possibilities for the second. Then, right in the middle, right in the area of the grid, will represent the possibilities for the sum. So then here we have so I have the sum would be, here would be 2, here would be 2, 3, 4, 5, 6, 7, here will be 3, 4, 5, 6, 7, 8, here will be 4, 5. So we're just adding, right? So like for here, we're adding 4 and 1 because this is saying you threw a 1 and a 4, that's 5. This is saying you threw a 2 and 4, that's 6, and so on. Okay, so what's the probability a total sum of 7 will appear? A total sum of 7 will appear. So let's count. How many 7s do we have? 1, 2, 3, 4, 5, 6. All right, so that's 6 over 36 because the total number of possibilities is 36, right? Which can be written as what? 1 out of 6. All right, for question 84. All right, so for question 84, we have What's the probability that an integer selected from the set of integers is a prime number? So between 20 and 30. Okay, so I'll just list them out, right? Let me list them out. We have 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Okay, so what's the probability that it is? It is what? Is a prime number, right? Okay, good. So let's select the prime numbers. Here are the prime numbers we have. 23 is prime. 29 is prime. Not prime, not prime. Not prime, prime, not prime, not prime, not prime, not prime, not prime, prime, not prime. So that's 2, right? And if you count how many there are, it's 2 out of 11, right? So if you count them, there are 11 of them, all right? So that's 2 out of 11. Finally, question 85. Which of the following is not a probability of Mary scoring 85% on a math test? All right. So the only one that does not qualify as a possibility is 1.01. You see, because your probability must always range from 0 to 1. You can't have a probability greater than 1. 1 is certain. All right. 1 is it must happen. All right. And 0 is it cannot happen. So it can either be less than 0 or greater than 1. All right. So yes. So that's the end. Good luck.